So I have looked at the size and shape of this graph. I know what the general shape is, and I know the size is determined by this value. So can I generalize this idea? So let me think of my coordinate space, and what are the points going to be where the lines intercept either of the axes, right? So this point is going to be a comma 0. Maybe you should go back and check what was the value here in previous example. It was 5 comma 0. So just instead of 5, I'm writing in a and generalizing the idea. This side is going to be minus a comma 0. This point is going to be 0 comma a. The value of x is 0 and the value of y is going to be a. This point is going to be 0 comma minus a. The value of x is 0, the value of y is minus a. And the graph will look something like this. And this is a square. I hope you figure that out one way or another. And now I want to generalize, let's say, at least the area formula for this, right? So this is the square and this is the diagonal of the square. So this is a and this is a. So the total length of the diagonal is going to be 2a. Now let's think about this side or the side of the square, and let's focus on that part of the story. I know this is a and I know this is a, right? It's a right angle triangle. This side is a, this side is a, this is the hypotenuse. What do I know? A square plus a square is equal to h square. This is the Pythagoras theorem, the most basic application, right? So what I get is a 2a square is equal to h square, and now I find the square root. What I'll get is a root 2 and an a, root 2 dot a is equal to h. That means the side in this story, the side of the square is going to be, side is equal to root 2 dot a. So what is the area of a square? Area of a square is s square. So what is the, if I square this, what will I get? I will get a 2a square. So now if the question was, let's say 6, and the question was only about finding the area, I could have done this very quickly using this particular formula. The area would have been 2 into 6 square. 6 square is 36, 36 into 2, your area would have been 72 units, right? So that's the advantage of having the general form. Now you can use a shortcut. Not that it's needed, not that it'll save you a lot of time. It's just that always once you learn the idea, get the general form going. That okay, what happens when the value is a 0, 0a, 0 minus a 0, etc. The overall idea, the meta diagram remains exactly the same as before. Just wrapping the story up, one more idea. The idea is already clear. One more, let's say, interpretation or application. So this is the story given to you. Mod of x plus mod of y is equal to 4. And now the question is, how many integer solutions for this equation? So again, first of all, think of your diagram. What are the coordinates going to be? 4 comma 0. Remember a 0. What are the coordinates going to be? 0 comma 4. What are the coordinates going to be? Minus 4 comma 0. That means you spend 15 minutes with the idea, or spend as much time as required, so that this step happens quickly. You have understood it, you spend time understanding it. Now do 2 more examples so that you are very clear about these kind of coordinates, right? Because that can add a lot of speed. What is this point going to be? 0 minus 4. And I know this is my shape. This line that I have drawn, doesn't it represent this equation? That means any point on this line is going to satisfy this equation. For example, this point 4, 0 will satisfy. 4 plus 0 will give you 4. What about the next point in the story? Because remember, we also have the table form, right? X is equal to 0, y is equal to 4 minus 4. X is equal to 1, y is equal to 3 minus 3 or 3. So when x is equal to 1, y is equal to 3. So this so when x is equal to 1, y is equal to 3. So this coordinate is going to be 1 comma 3. This also satisfies the equation. So what am I trying to learn right now? The shortcut will come in no time. What am I trying to learn? Any integer on the line is going to give me a solution, right, for this particular equation. but let's still go slowly. What is our next point going to be? It's going to be 2, comma 2. Of course, I can also plot it here and I will, but let me just finish the story. What is our next point going to be? 3, comma 1. And the last point is 4, comma, and the last point is 4, comma 0. Okay, count 1, 2, 3, 4, 5, right? And now you might think, okay, I got 5 integers and there are 4 sides. 5 into 4 is the answer 20. So think for yourself first of all, is the answer going to be 20? And I hope you have figured out, or maybe just manually counted and figured out that the answer is not going to be 20. And what is the problem? The problem is that of extra counting. What is it that I'm counting over and over again? So say if I say these are 5 points and this line will also have 5 points, right? But this particular point, and I'm going starting my cycle from this story, this is my starting point. I'm saying if I go step by step, on this line, I saw there are 5 points. And I'm thinking, okay, 5 into 4, 20 maybe is my answer, but it's not, right? And on this line again, there will be 5 points by the same logic, but one of those points has been counted already. So I should definitely subtract it, right? Similarly, I say, okay, now on this line there are 5 points and I have counted it and I have taken care of it. Whatever was the problem, I have sorted it out in my final solution. This line will also have 5 points. Again, this point has been counted in this line. So I am okay with multiplying, but I should do a one more minus to get the double counting out for this situation, right? And I have counted this story as well. Now again, this line will also have 5 solutions, which is what I have done in the multiplication. But this point will be counted one more time, right? So I will do one more subtraction. So I will do one more subtraction for this double counting. And now again, when I say this line has 5 solutions, I'm counting the last point, right? I'm following the order. This point I'm counting again. For example, rewind your story. This line you counted manually once, okay, this has 5 solutions. And then you went here and you said this will also have 5. That included the ending point. The starting point was counted again, you subtracted it. Again, go for this story. This, when you said this has 5 solutions, you counted the ending point and subtracted for the extra counting of this point. And once again, in this story, you say you have 5 points. This point has been counted in the previous story, so you subtracted 1. And this point also has been covered in the previous story. So 20 minus 4, what I get is 16. This is a long way of going about it. What would be the short way of going about it? And let's say, how would you discover it on your own? Best discovery would be to change the story to a mod of x plus mod of y is equal to 5 maybe or 6 maybe, and then start counting again. The repetition brings the pattern and the observation, right? So this is still long. My short point would be that each of these boundary points are always getting counted twice. So I need to count them once, but overall they're getting counted twice. So overall I should just subtract a minus 4 from the story. So my final answer one way or another is going to be 16. If you're doubtful about it, if you're doubtful about it, go step by step, count each of the points once, and then you will see your final answer is 16. But there is never any point in putting this much effort and counting, finding out only one solution. Is there a pattern? Can I create a shortcut between this value and this value maybe? And one more example should ideally reveal that. Back to this story, mod of x plus mod of y is equal to 5. And I say how many integer solutions for this story, right? That means once again, think of your graph. What are the points going to be? 5, 0. What are the points going to be? 0, 5, 0, minus 5 and minus 5, 0. And what is your shape going to be? It is going to be so. Because now I have the pattern in my mind. Now let's start counting the integers. 0, 5 is a solution. 1 and 4, I'm just going on this one line. 1 and 4 will be the next solution. 2 and 3 will be the next solution, right? 3 and 2 will be the next solution. 4 and 1 will be the next solution. And the last on the line will be 5 and 0. So how many solutions do I get? 1, 2, 3, 4, 5, 6. So I have 6 on this line. I have 4 such lines. So can I do 6 into 4 is equal to 24? Yes, I can. What is the problem in that counting? this point and this point and this point and this point are being counted twice. How are they being counted twice? For example, this location was counted in this story and counted will be again will be counted in this story. This location was counted in this story and this story, right? So these 4 points are being counted twice. I should subtract and my answer will be 20. Okay, let me go back to my story now. Mod of x, let me go back to my original story. Mod of x plus mod of y was equal to 4 earlier and my answer came out as 16. So maybe some of you would have thought about, okay, maybe this is 4 square. But in this answer, I'm not getting 5 square as 25, right? So, okay, but for 4 it is 16, for 5 it is 20. Is there a pattern? Maybe just multiply by 4 and you shall have your answer. Now, I observed it. This is empirically true for these two examples, but is it necessarily true for all given situations? So let's try one more example, and if the logic works out, we'll have a very good bonus shortcut. Let's go small. The number is 3. What are my coordinates going to be? 3, 0, 0, 3, 0, minus 3, minus 3, 0, right? The shape is so. And my question is once again, how many integer solutions satisfy this equation? So just like these 4 points satisfy this equation, any point on the line, any integer, it's not even saying any point, any integer on the line will also satisfy. Let's quickly look at the story. 0, 3, one solution. 1, 2, another solution. 2, 1, another solution. 3, 0, another solution. How many do I have? 4. I will have 4 per line. 4 per line. How many lines? 4 lines. So 4 into 4, 16. And 16 minus 4 is equal to 12. Oh wow. That means you look at this number and just multiply it by 4 and you shall have your answer. This should be enough. And of course, now if you observe what is happening with a little more detail, you will see, yeah, of course, I know why this is always going to be true. But I'm saying as a learning method, you saw 3 examples, it is always happening. Now you have a formula shortcut ready that if you see a situation like this and the question is just integral solutions, just take this value and multiply it by 4, right? So that is the advantage of creating a general form. The first big advantage is obviously knowing how to create a table and then being able to plot it on the graph paper or let's say in your mind. Then after that, a little bit of extra play can give you a lot of these small shortcuts in case a question like this comes, and you can do it in maybe less than 5 seconds because you know the final value, right?